Hello, and welcome to Programming with Jim. Today, we are going to cover the basics of programming a robot to drive forward until it hits a wall. So for our example, suppose you built a rover, and you want this rover to drive forward until it hits a wall. To understand how to program a robot to do this, let's see what it would take to program your friend to do it. You tell your friend you want him to walk forward till he gets to this wall. It's dark, and you need him to go to that wall for some reason, and he can't see the wall. So how is he going to know when he hits the wall? A touch sensor. What kind of touch sensor? The most fantastic touch sensor he has. His hand. So what he's going to do is, instead of having his hand off to the side like this, he's going to have his arm outstretched and his palm up as he walks toward the wall. So that when his palm makes contact with the wall, his hand will tell his brain that it's touched something, and then his brain will remember it's time to stop because the wall is there. Now, let's write a program for your friend. We're going to write a program that tells your friend how to walk until he hits a wall. Let's break down walking first. Walking is really just stepping over and over. So, right foot, left foot, right foot, left foot, right foot, left foot. But it'd be a lot to draw all of this walking all the way to the wall. So instead, you're going to put it in what's called a loop. You want him to repeat this action over and over again. So you're going to put walking in a loop. So what his brain is going to say is, what do I need to do? Walk. Okay? Now what question is he asking? Did I get to the wall yet? So his loop condition is going to be his hand. So what he's going to ask himself is, okay, walk. Is my hand touching the wall? If it's not touching the wall, he needs to keep walking. So he's going to go back to the beginning and keep walking. And he's going to repeat this process over and over again. So he's going to take 2 steps, see if his hand is at the wall. Hand's not at the wall, do it again. Take 2 steps, and he's going to repeat this until his hand is actually pressed. And once his hand is pressed, he's going to know that it is time to stop. And then he's going to stop walking. This is exactly what your robot's going to do, except that we're going to swap out a few things. The first thing we're going to swap out is the hand. Your robot doesn't have a hand. Your robot has a really simple touch sensor, probably in its bumper. Looks sort of like this, where this is the part you can press. Your robot doesn't have legs, but your robot does have wheels. So let's get rid of the feet because we're not stepping, we're rolling. So suppose instead of taking 2 steps, you're rolling your tires all the way around once, or part of a turn. So let's look at how your robot's going to do this. Your robot is going to say, what's my first instruction? Drive, roll my tires. Okay, did my touch sensor, my bumper sensor get pressed? No. Back to start. Roll tires. Did my bumper sensor get pressed? No. Back to start, roll tires. Did my bumper sensor get pressed? No. So it's going to do this repeatedly. And it's going to keep on asking itself if the bumper sensor gets pressed till finally your little rover robot makes it all the way to the wall and the bumper sensor is pressed. So then he's going to go, did my bumper sensor get pressed? Yes, it got pressed. So now we're done with this loop and we're exiting. And what's our next instruction? Stop. Our next instruction is to stop the motors. This is a good simulation of what your NXT program will look like. You're going to have a loop that tells your robot to do something over and over. You're going to have the drive command, the command that your robot's going to repeat over and over. You're going to have a loop condition that says why you should stop repeating whatever it is you're doing. And then you're going to have more commands later. Maybe stop commands, maybe whatever you've decided your robot needs to do next. So now that we've covered concepts here, let's move on to my laptop and see what it looks like to tell a robot to do this.
We're back at the computer. Let's look at how we can implement the code that we wrote on paper in real programming language. We're going to start with a loop. The orange tab is flow control. We're going to take the loop and put it right here on our program, since that's the first thing that happens. Inside the loop, we want to tell the robot to drive. So we're going to go to the Action tab and click Move Tank, which means drive. I'm going to drop it in there. Now, when you have something inside of a loop, it's usually better to just do on instead of on for rotations. We can worry about those details another time. Loop condition. We need to change this loop condition right here to something else. Right now it's set to unlimited, which means that you'll drive forever. These are your options for stopping the loop. As you can see, there's a lot more than a touch sensor. You could push a button on your brain. You could use the color sensor, infrared sensor, motor rotation, timer, touch, ultrasonic. We're going to start by setting it up with a touch sensor. Touch sensor state. Now the state we want is pressed because it will be pressed when it hits the wall. After this, we want the motors to stop. So we're going to take another move block and we're going to put it after this. And instead of being on, we're going to tell it to be off. So stop the motors. And as an added bonus, we can put a program stop command in. So, which is under advanced. Pop that right there. And what we can do now is actually test this program to see how well it works. I have a robot handy, so let me get him out. Robot. It's a tank drive robot, as you can see. And right here, there's a touch sensor. So the way this works is when I press it, it registers that it's pressed, and I release it. It registers that it's released. So what we're going to do is we're going to try out our program on this robot. I'm not going to run it into an actual wall. I'm just going to see if the motors will stop when I press the touch sensor. So back to the program, what we're going to do is we're going to try out this program. There is a run button right here, compile and run. And you can click that. And it's running right now. So as you can see, this section of code is highlighted, which means that just like I showed you in the earlier video, it's running this loop over and over and checking to see if the touch sensor is pressed. Watch what happens when I press the touch sensor. Voila! The program ends. So this loop ran until it detected that the touch sensor had been pressed. Once the touch sensor was pressed, the robot stopped moving because it reached a wall. Now in my case, you can see that my robot really doesn't have a bumper. It actually has an ultrasonic sensor or infrared sensor. This can detect distance by sending out a signal and counting how long it takes for the signal to get back. So what we're going to do to finalize this is we're going to switch our loop to work on the ultrasonic sensor instead of on the touch sensor. So coming back to the program, all we have to do is change this loop condition. Click on the loop condition button, go to infrared sensor, the one that looks like the one on the front of my robot, and go to proximity. Less than or greater than are your options. So because we're looking to hit a wall, we want to do less than. For less than 50, let's do something smaller, less than 25. So if this sensor reads less than 25, then what we're going to do is we're going to tell the robot to stop because he's pretty close to the wall. Let's see how well this works. This time I'm going to use my hand, and if it works out well, we can test it in my apartment. So I'm going to go back over here to the download and run button. I'm going to click that. It's driving. It's once again repeating this loop because it hasn't got the infrared sensor that close yet. So I'm going to take my hand and I'm going to bring it close to the sensor. You'll notice that when I got close enough, the robot stopped turning its wheels because it knows it's at the wall. I think this program is ready for prime time. Let's try it out with my robot and a wall in the apartment. With the robot software updated, we are now ready to see if it will stop closer to the wall. As you can see, the robot did a masterful job of stopping at the wall, so that means that we have completed our task for this sensor. What you can do from here is you can apply this same concept to other situations, but for now, that should be enough to get you started with programming in LEGO Mindstorms. Thanks for watching!